So we're continuing with 6-3 videos. This is 6-2, video number 3. So these are, again, money problems, if you want to think about them that way, where we're earning interest. But for these, what you want to look for in the problem is this magic word where it says that interest is compounded continuously. So what that means is instead of waiting until the end of the month or the end of the week for them to calculate your interest, they're doing it continuously. So if you put $100 in and say, for example, 1 minute later, you earn 5 cents in interest. So now you have this. This would be the new balance that they calculate your interest on. So it happens, if you want to think about it, instantaneously. Obviously, with computers, that is possible. So they're not waiting till the end of a time period to calculate your interest. They're doing it constantly or continuously. And that's where our e to the x function comes in. So if you're wondering why we learned all about e to the x, this is why. So this is your definition. It says when interest is compounded continuously, the amount A in the account, so A, which is right here, is your final amount, after T years is given by this formula. A equals P times E to the RT. I wrote it bigger down here. We often refer to this formula as PERT, because if you look at this side, it spells PERT. So let's put some labels on here. A is your initial or starting amount. No, scratch that. Hope you guys aren't writing in pen. If you are, you shouldn't be, and that's why I make mistakes. P is your initial or starting amount. And again, that is the finance word for the money you're starting with is called your principal. A is your final amount. So in our other formulas, this is like your Y, your output. Right, when we did our other formulas, they looked something like this. Y was the final amount, A was the initial amount. So you can think of A as similar to your Y in the other formulas. P is your initial amount, which in our other formulas was A. R and T are the same. So R is interest rate. And then I'm just going to put divided by 100 there, so we remember to turn it into a decimal. And T is time. Okay. Generally, when your interest is compounded continuously, it grows faster. So this is good. This is what you want to look for when you're putting your money into a bank or some kind of financial institution. So let's look at example 4. Suppose you deposit $700 into an account. So right away I'm thinking, oh, this is my starting amount. I'm depositing $700. So I'm going to say, that's my P right there. Because remember, starting amount or initial is P. Into an account paying 6%. So there's my R. I'm going to put R equals 0.06. I already did the 6. Show you here. 6 divided by 100. Yeah, I did times. Clear that. Okay, I'm going to make all the mistakes you guys shouldn't. 6 divided by 100. 0.06. Remember, you cannot do math on a percent. You have to turn it into a decimal. There's my magic words that tell me I need to use the PERT formula. And what else do we have here? 8 years. So T equals 8. All right, so it says use A equals P times E to the RT. So use PERT. What are we solving for? What is the balance after my money is in the bank for 8 years? So I'm solving for the final amount. So I'm solving for A. So I'm going to start with, I'm switching pencils here. I'm going to start with writing the formula. A equals P times e to the RT. And remember, e is that number in your calculator. It doesn't represent anything. So on this calculator, here's my natural log button, and there's my e to the x. So the e in this formula is actually that function. Here's my 84. It would be the same on the 83. Here's my natural log button, ln. I say natural log, you guys don't know what I'm talking about, ln, and there's my e to the x. So these two always go together. Okay, so now let's fill in what we know. A is our question mark, right? That's what we don't know. So A is going to stay. P, we said, was initial amount. Well, we're starting with $700. E, that's that function, so just write the E. R is 0.06 times T, which we said was 8. Now, you can punch all this in your calculator. Notice those are all numbers. So I could put that in the calculator and simplify it. I'm going to recommend you multiply these two numbers first, because you can get into some mistakes if you don't punch this in exactly. So I'm going to say let's put 0.06 times 8 in our calculator first, and we get 0.48. So I'm going to keep going here. A equals 700 e to the 0.48. Okay, now I can go ahead and put this whole thing in my calculator. So let me clear that. 700. Now I'm going to find that E button on this calculator. It's right here. So it's second ln, or second natural log. And you can see, I'm going to try turning this light on, see if this helps. Helps a little. So you can see it automatically makes the exponent for you. So it automatically puts this, oh, that kind of makes a bad shadow. Let me turn that back off. Automatically jumps it up so that when I put in this 0.48, it already is an exponent. And then I hit enter. And I get 1,131. That is a number that makes sense to me. If I start with $700, it does make sense to me that I would get something around this. Remember, if you get a really weird number, you probably made a mistake, right? I shouldn't get a number like 10,000. That doesn't make sense. I also shouldn't get a number less than 700. So 1,131 makes sense. Remember, this is money, so I want you to round to 2 decimal places for the cents, 25 cents, and you must have your dollar sign. Okay. Now part B says, how long? So when you think of how long, that's time, right? So this is having me think, ooh, I'm solving for time on this one. Will it take for the balance in your account to reach 2,000? So this is saying if I put $700 in, how long until I earn 2,000? Well, this is my final amount. So the final amount, again, remember, is A. So this means A equals 2,000. T is what I'm solving for, so that's a question mark. So it tells me to use PERT. I'm still in this same continuously compounding problem. This is just part B. But what am I solving for this time? T. So T is my unknown, or my question mark. So when I fill in all the pieces of information that I know here, T will be my unknown, or my variable that I'm solving for. So this says, remember, T is the input and A is the output. So we kind of talked about that a little bit up here. We said our original formulas looked like this, where Y was our final amount and T was our time, our input. So that's what this is reminding us of. T is your input, so you can think of that like your X, and A is your output. That's like your Y. And the reason we're talking about that is because we're going to solve this on a graph. So we need to remember on the graph we use X and Y's. So we will use the graph in Desmos, to find the X that gives a Y of $2,000. So let's fill in what we know here. A equals P e to the RT, so that's my formula. I know A, it's $2,000. My initial amount is still the same. I'm still starting with that 700 like I did in part A. E, the R is still the same. What was our R again? 0.06. And then times T, it's RT. So T is what I don't know. So the way we're going to do this is solve this by graphing. We're going to put this into Desmos. So it's going to look like this. Or we don't even have to put the Y equals, so we can just put this right into Desmos. So I'm going to type this in to Desmos and kind of try to show you, I'm going to move my phone here, how to do this. So let me mess with this so I can have you see my computer screen. Let's tip that up a little bit. Okay, that's not bad. So I'm in Desmos. desmos.com. I typed in the 700, and now I can just type in the letter E, and then I want to use, remember this is the button where I get my exponent, and for my exponent I want to put in 0.06, and then I want to put in X. Let me see what happens if I put in T. Yeah, if you put in T, it doesn't like it. You need to make that an X. And if you look over here, you can see I have a graph and it shows exponential growth. Now, what I want to find out is, when is my output 2,000? So you can see these are my Y values here. So it's way up here somewhere. But a better way to find this is to use the table. So we're going to go to this gear again. We're going to click on that gear. And then we're going to click on the table. And it starts me with these -1, 1, and 2, which right now don't look big enough, because this says when X is 2, so after 2 years I have $798. Now what I'm trying to find out is, what is X that will give me a 2,000 over here? Well, I'm not even at 1,000 yet, so I'm going to put in a little bigger number. And this is just where you just try it and see what happens. I'm going to try 6. So I can see 6 took me all the way up to 1,000. So I'm going to try 10. And I'm just trying numbers here. That's 1,200. So I'm going to try 14. 1,600, 1,600. I'm going to try 18 just for kicks. Okay. So this took me over 2,000. So I'm going to go back 1. I'm going to change that 18 into a 17. Okay, there we go. This is getting close. So 17, when X is 17, Y is 1,900. So let's see what happens when I put in 18. So there we go, 2,000. So the question asked, how long will it take the balance in your account to reach 2,000? Well, after 18 years, I'm over 2,000. So we don't know exactly when. So the way we're going to answer this question is we're going to say between 17 and 18 years. Okay, now let me try to get this back to my paper. And the way we're going to answer this question is, that's a little close. The way we're going to answer this question is, we're just going to simply say, so we solved this on the graph, so there really isn't any work here, and we're just going to say between 17 and 18 years. That's how long it will take to get $2,000. Okay, I am going to stop for this video. It's already 15 minutes.